The story of the cosmological constant. Yes, I am talking about cosmological constant, means this constant denoted by capital lambda was introduced by Einstein in his equations for a reason. Okay, and thereafter many changes are there. So those things I am talking about or discussing in this video. So first, you know that in 1915 a general theory of relativity was discovered by Albert Einstein in the year 1915, and at that time what was known about the universe is that the nature of the universe was static. At present, you know that the universe is expanding, but at that time, during the time of Einstein, especially in the year 1915, okay, during his discovery of the field equations, those equations are known as field equations. Okay, so it was known that the universe was static, but Einstein, after the discovery of his field equations or after the discovery of his general theory of relativity, he realized that the equations are describing a dynamic universe, not static. So, as a solution to the problem, he introduced a constant known as cosmological constant, which is denoted by capital lambda. Capital lambda, this is a Greek letter. Okay, looks like this. Okay, so known as capital lambda, introduced by Einstein in his equations. But again there was a problem. In the year 1920, okay, 1920s, Edwin Hubble discovered that no, the universe is not static in nature. It is actually expanding. Now I am talking about 1920s. That time means just after 5 years from the discovery of general theory of relativity, Edwin Hubble discovered that no, the universe is not static in nature, but it is expanding. Then again Einstein realized that, oh, that was his blunder mistake. He admitted that introduction of the cosmological constant was his biggest mistake. Einstein admitted this. Okay, so he decided to discard the term lambda or the cosmological constant because the nature of the universe is expanding. It is not static. That means the original equation, which was without lambda, that was correct according to Einstein. Okay, but again in 1990s, means almost 70 years after 1920s, in 1920s, what was discovered? The universe is expanding. But in 1990s, what happened? Scientists discovered that not only the universe is expanding, but the universe is expanding at an accelerated rate. Means the expansion of the universe is accelerating. Okay, scientists discovered this thing. Scientists or physicists or astronomers, they discovered this thing. Then again, scientists thought that lambda should be used, means that cosmological constant should be used here in these field equations of Einstein. Okay, so when the universe in 1920s, when it was discovered that the universe is expanding actually, then in that case the introduction of lambda was thought to be as a repulsive force, means force which is acting against the gravitational force. Okay, that was taken as or accepted as a repulsive force in nature. Again here, when in 1990s they discovered, when scientists discovered that there is an acceleration of the expansion of a universe, then again there was a need to reintroduce this cosmological constant. Okay, but this is not the end of the story. This is not the end of the story. Okay, lambda has been introduced, means lambda was introduced in late 1990s by the physicists. After that, what happened? After that, and according to the scientists, this cosmological constant, it exists at each and every point of the universe. That means this fills all of space. Okay, according to the opinion of the scientists. But measurement of the vacuum energy, sorry, not measurement, prediction about the vacuum energy revealed that the predicted result is much more greater than the observed result, observed value of cosmological constant. Okay, the predicted value of vacuum energy is much more greater than the observed value. That means there is a problem with the cosmological constant, and that problem is known as cosmological constant problem at present. That problem is known as cosmological constant problem. Anyway, this lambda plays a crucial role in the Einstein's field equations and to explain the observed phenomena of accelerating expansion of the universe. There is one model known as lambda CDM model. Lambda, Greek letter lambda is at the first position, then CDM. Okay, lambda CDM model, which is a standard model for the cosmological constant. Anyway, in that model of cosmological constant, this lambda is used greatly. Anyway, so again, what is the result? At first, what is the conclusion? At first, there was no lambda or there was no cosmological constant in the field equations. Then cosmological constant was introduced by Einstein. Then he realized that introduction was not necessary, that should be discarded, and he admitted that lambda was his biggest mistake. Okay. Then again, there was a requirement of reintroduction of the same constant, lambda. Then experimental results and predicted results are different. That means what is the requirement at present? At present, the requirement is to modify everything, means to modify the field equations, to modify the laws of physics. Actually, many things are still unknown. And that cosmological constant, okay, that takes care of dark energy. Okay, dark energy. Anyway, for dark energy, I have already posted 2 videos in my channel, so you can watch those videos about dark energy. Anyway, so I am not discussing here in this video dark energy. Anyway, that cosmological constant that explains actually dark energy. The presence of dark energy is taken care of by that cosmological constant, because dark energy is considered as a repulsive force in nature, which is causing the accelerated expansion of the universe. Okay. Anyway, conclusion of this discussion is what? Cosmological constant is highly important, and we are in need for modifications of the existing equations or existing theories. Okay, then only we can fully explain the phenomena observed by us or the phenomena observed by the astronomers or physicists. Anyway, so this was all about today's topic. The story of the topic was story of the cosmological constant. Okay, so this is the end of this video. Thank you for watching this video.